Hey everybody, welcome to another Doug's Lab video. This video is being made in response to a request from Home Alchemy because he wanted to know, or he wanted to see how I determine the concentration of my hydrogen peroxide. So I'm going to show that whole setup and what I do to do that. Right here we have a test tube, and this is the decomposition vessel. And in the bottom of this test tube will be placed a very accurately known quantity of hydrogen peroxide in test. And it will be decomposed by a chunk of manganese dioxide, and I harvested this from AA batteries. It's been washed and processed and things like that, but essentially that's where it came from. And of course we have a tightly fitting cork with a tube, and this thin tube goes into this graduated cylinder, and this big coffee pot here gets filled with water, and the graduated cylinder gets filled with water and inverted in the coffee pot so that we have the whole thing filled with water. And then, of course, the oxygen gas produced in the decomposition flows to the tube and comes out of the end of the tube and collects in the bottom of the graduated cylinder. And then, of course, then we can use the graduated cylinder to measure how much gas we had given off, or the reaction has given off. And then, of course, the amount of gas given off can be translated to a concentration of hydrogen peroxide. So today I'm going to do two samples of hydrogen peroxide. The stuff that we boiled down, unknown concentration, and, of course, a standard should be 3% in concentration, though it's kind of old, so it might be slightly less. And we're going to be decomposing exactly a 1 milliliter sample using this 1 milliliter pipette. In fact, I have several other 1 milliliter pipettes, but and they're graduated, but this one's easier to use. This is the volumetric one. So, and I also seem to have misplaced my pipette bulb, so I'm going to have to cut the video and then set this up. So, all right, we'll be back in a minute. Okay, so the experiment's all set up now. I have exactly 1 milliliter of the unknown hydrogen peroxide from that beaker over there, pipetted into this test tube, and there's some sticking to the walls. I suppose I should probably wash those down, because it won't matter if you change the concentration now, because we know there's exactly 1 milliliter of the unknown, and we can obviously calculate back to that regardless of how the concentration changes in here. So anyway, this is the setup here. You can see this is full of water, a bit of condensation on it. And of course the gas tube goes up inside there. And one thing I forgot to mention, there's a piece of wire, little hooked piece of wire that's taped to the tube, and that makes it much easier to get the tube inside the graduated cylinder. I forgot I'd taken that off before, but just something I thought I'd mention. And so yeah, we're ready. We have the manganese dioxide ready to go. I'm going to put a small chunk in there and put this cork on, and then we'll see decomposition, and obviously we'll collect gas, and then I'll let it go until we're done collecting gas, and then we'll see what the concentration was. So, a little piece of manganese dioxide. I'm going to drop it in, and put the camera here so you can see the action. Okay, ready with the cork. 3, 2, 1. Cork's on. Alright, and as you can see, we're already collecting gas. And it's just that simple. And of course, I'll tell you the calculations on how to find the concentration of hydrogen peroxide based on how much oxygen you collect. But also, I thought I'd mention that not only is this useful for calculating the concentration of hydrogen peroxide, but many other things as well, like the concentration of vinegar, for instance, or any acid for that matter, because what you can do is use sodium hydrogen carbonate, and sodium hydrogen carbonate will react with an acid to release carbon dioxide gas. So if you always have an excess of sodium hydrogen carbonate in the test tube, and you add an unknown amount of acid, or a known amount of an unknown concentration of acid, and collect all the carbon dioxide produced, you will eventually, or once all the carbon dioxide has been collected, you can trace the amount of carbon dioxide back to a molar equivalent of sodium hydrogen carbonate, and thus the molarity of the acid. So that's easy for, you can experimentally determine the concentration of vinegar or something, acetic acid in vinegar. So I thought I'd mention that. Anyway, this is going to take a while, so I'm going to let it run, and I will show the results when it's done. Alright, experiment has not run totally to completion. I mean, as you can see, there's still a little bit of effervescence going on, but the majority is decomposed, and it's getting late, so I'm just going to do this right now. Anyway, so yeah, you can see we definitely have a lot of gas collected in the cylinder. And if we get really low, we can tell that it's about, we have like 99 milliliters. So, 99 milliliters of oxygen gas was given off by 1 milliliter of our unknown hydrogen peroxide. And doing some simple math, we can easily figure out what the concentration of the hydrogen peroxide was. So, in fact, I can probably just do that right now. Get this. Alright, let's see here. Kind of notes. Alright, alright, so let's see here. This is a fairly simple calculation to do. We know we have 99 milliliters of oxygen gas produced. So let's start with this. We know hydrogen is 1.00794 atomic units, or grams per mole. So we can just call that 1. Oxygen is 15.9994. These are all common values, so I don't know off the top of my head. So we can call this 16. Oh, my camera's not focusing. Okay, so that means H2O2. Well, we can easily call it's 15 or 16 times 2 plus 2. So we'll call that 34. So hydrogen peroxide is 32 grams per mole. All right, so we have 99 milliliters of O2 gas, and we need to know how many moles of gas it is. At standard temperature and pressure, 22.4 liters of gas is equal to 1 mole of any gas. So 99 milliliters, we convert that into moles. So 9 milliliters times moles over 22.4 is equal to, this is here, 99, oops, divided by 22.4. And of course we are using liters down here. So we're off by a factor of 1,000. So this is 0.004196 moles of oxygen gas. Alright, and then we're going to convert moles of oxygen gas into moles of hydrogen peroxide, because we know we had 1 milliliter sample. So we know we have to start with this equation first. H2O2 decomposes into H2O and O2. And as you can see, this is not balanced, so we throw a 2 in front of here. So here, 2, 4, 4, oops, yes. So there, now the equation is balanced. So we know if we have this many moles of oxygen, that means we have twice as many moles of hydrogen peroxide. So we take this value, we multiply it by 2. First I'm going to divide it by 1,000, just so we know we're on the right track here. So that means we have 0.8839 moles of H2O2. So 0.8839 moles of H2O2 per milliliter of the solution that we had in the test tube. And so to get moles per liter, we obviously just have to multiply it by 1,000. So times, which is kind of stupid because I just divided it by 1,000. So this is 8.83 molar, or 8.84 molar hydrogen peroxide. And that's the solution. So it's 8.84 molar hydrogen peroxide, what we had in this tube over here, and what is in that beaker. Now what is that by percent? Well, that's a difficult one to calculate because you need the density of this hydrogen peroxide in here. And I can do that actually by weighing a sample. I could tear out a graduated cylinder on my scale and get a density value for that. But yeah, that's pretty easy to calculate once you know the density. But it's getting late and I really don't want to do that right now. But a good rule is that 3% hydrogen peroxide is called 10 volume hydrogen peroxide because it generally gives off 10 times its volume in oxygen gas when fully decomposed. So, and this is actually decently accurate. This is what they use in like the hairstyling industry for hydrogen peroxide. So if we know that this 1 milliliter gave off 99 milliliters, or it's still going, so we can just call it 100 for easy numbers. This means that this gave off 100 times its own volume. So it should be 10 times as concentrated as 10 volume hydrogen peroxide, which is 3%. So we can assume that this was around 30% hydrogen peroxide. So it might not be 35, but this has been sitting around for the 3 weeks, just like that actually, in that same position for the 3 weeks since it's been that I've made the video for concentrating it. So, and of course I could have continued to boil it theoretically. I don't know what the maximum amount of hydrogen, or maximum concentration of hydrogen peroxide it could get is, but maybe I should find that out one day. But anyway, so yeah, that's determining the concentration of hydrogen peroxide. Subscribe, rate, comment. Thanks for watching.